So our next speaker is a celebrated thinker in the area of privacy and security, Katherine Jarmul. She is the principal data scientist at ThoughtWorks, and ThoughtWorks is a consultancy that focuses on privacy, ethics, and security for data science workflows. And so she has got decades of experience in implementing data processing and machine learning systems with a focus on reliability, testability, privacy, and security. And she's also a prolific author in the area of O'Reilly. And so if you've seen O'Reilly books entitled Python and Web Scripting or Data Wrangling with Python, they were written by her. And moreover, in this year, in the last few months, in fact, she released a brand new book entitled Practical Data Privacy. And I gave it a quick read recently. It's a fantastic book. I really encourage you to read it and sort of digest the messages that it has. So thank you very much for coming today to speak for us.
Thank you. Yeah. Thanks for building Flower. So that was chapter 6 is on distributed machine learning, which I use Flower because it was a delightful experience, especially compared to the joys of TF Federated. All right, so today I'm going to talk a little bit about an industry perspective on deploying distributed learning. Just a quick note, why do I call it distributed machine learning? Because I used to work in the field of encrypted machine learning, which is also distributed in many cases and is slightly different than what we would consider federated machine learning. So I think distributed learning is maybe an umbrella term that we can think about for a few of these different use cases where the data needs to stay in a distributed form when we do training. And I completely redid my slides this morning because I was really inspired by everything that was happening yesterday. And a lot of the kind of baseline challenges that I outlined in my original slides were things that were already commonly talked about yesterday. So if you're just joining for today, you should watch all the videos for yesterday. It was amazing. And here's some of them. And I've kind of tried to cluster topics in ways where I see them as, or potential solutions also as connected. And so we have a problem of thresholds and determining thresholds and dropout mechanisms. We have a problem with cross-device software and updates, particularly in a cross-device capability. Related to that or in the same region, we also have participation selection and the distribution. This can be a representative of our overall population or a particular goal that we have for the learning that we're trying to do where we want the distribution to have particular qualities. With that, we start to think about quantifiable privacy. It was awesome to hear so many people bring up privacy. And when I think about privacy, I always think of quantifiable privacy, so differential privacy guarantees or mechanisms that can still provide differential privacy guarantees regardless of if we use a differential privacy mechanism. And so we can look to some of Google's research on that space to think about ways that encryption and shuffling and randomization at internet scale can also provide differential privacy guarantees without a particular differential privacy mechanism. And then we have the problem of vertical splits, which I think a few folks touched on yesterday, but in industry becomes very prominent. More on that in a minute. And we have the same problem of multitask learning, or also touched upon briefly yesterday in some of the work. How do we think about unsupervised or semi-supervised learning where tasks may even be distributed across different geographies, different devices, and so on and so forth. So yesterday was amazing. I feel like it's such an honor to be here and to listen to a lot of your work. I really appreciate it. And so when we think about then shifting to an industry focus, and this is so based off of my experiences, which is of course biased, but it's some things that I think I've seen in a real world context, we start to add these clusters of extra things. So just trying to go from the top. We have input validation problems. So we constantly have transformation problems or what we would consider valid ranges for things, and the input doesn't fit those formats, which leads us maybe also to this cluster of pre-processing, where we start to think about how do we actually get the data in the appropriate shapes and the scale that we need to do real learning, and how do we do so in a privacy-aware way. So one of the problems that I'd like to talk about today is privacy-aware debugging. So we run into a problem where either on a client point of view or even in a cross-silo sense, the model isn't converging, or there's some other problem that's happening. How do we actually share metrics during learning that are also privacy aware so that it doesn't immediately leak the information that we're trying to protect? This is a hard problem. If you've solved this problem, I would love to hear about your work. Please find me or just raise your hand. From a semi-supervised or unsupervised point of view, and I was a little bit surprised yesterday that the Google leaked memo was not mentioned, and that also some of the new inroads in language modeling was not mentioned. But in case you didn't read the Google leaked memo with the "we don't have a moat and neither does OpenAI," one of the core points of this is the fact that data quality, particularly when we start thinking of a fine-tuned and domain-specific language model, which I believe was part of what FedGPT is aiming to do, is superior to data quantity in the way that we're doing language modeling. Yes, of course, then you need a base language model, but now we have open source based language models. And I just saw a paper that got released last week on this specific issue of when you have high quality domain-specific language for fine-tuning, these models are now outperforming even the ChatGPT on some particular tasks, right? So when we start to think about a federated point of view, where we can get higher quality data, where we can often get less toxicity, we can start to think about actually democratizing some of these language modelings or even other semi-supervised or unsupervised tasks and think through releasing better quality models. To go to the left-hand side here, we have serious audibility and reproducibility problems when we deal with federated computations, particularly in a case where we need to guarantee confidentiality or we need to have certain guarantees that particular cybersecurity or privacy policy was preserved. We end up in a space where we need an auditable, traceable, reproducible computation. And this is really important that we get that in a form that, let's say, if somebody comes knocking, like a regulatory force or an insurance force or a liability and compliance board, that we have a real reason to say, here's the privacy mechanisms that we use, here's the ways that we came up with the model that was trained, here's the participants for that particular model, here's all the information that we have. And particularly in the field of finance, this is really important. That leads me to the concept of secrecy. So one of the things that we talked about yesterday was privacy. I think privacy and differential privacy is well understood, particularly by this group. But one of the other things we have to think about is secrecy. And that comes more from the cryptography side of the house. And it's the idea of when do we know who can have access to decrypt a particular piece of data? And can we put protocols that say this particular piece of data can never be decrypted, or this particular piece of data can only be decrypted after, let's say, a differential privacy mechanism, or at this particular stage in a computational graph, et cetera, et cetera. And so I think when we think through secrecy, this becomes a huge thing in industry, because if you're dealing with nation state level problems, if you're dealing with financial industry problems, absolutely secrecy becomes the core reason why people are pushing to a distributed context. And finally, at the end, we have user-defined consent. So GDPR enforcement is increasing. The AI Act in Europe will also increase viewing of these types of things. And what I was inspired to hear some people thinking about yesterday is, how do we actually think of offering a privacy that's not a binary on-off, but where people can tune their contributions and their ability to contribute to these models in a user-defined consent or in a user-defined flow. But I want to touch really quickly too on one of the most unspoken things that I see in industry, and it's the question of trust. And obviously I worked mainly in the encrypted space, which means trust is fairly central in thinking through those things. But also I think trust is something that I notice now, even just in talking with people about using more private data in these types of formulas, right? And one of the things that I want you to think about, as if you're a researcher, as you work in research, and if you're in industry, I'd love to talk with you about methods that you've developed from talking with stakeholders about these types of things. But one of the things that I see in getting further adoption of distributed machine learning is kind of removing the fear, the anxiety, and also re-incentivizing people to share data in new ways. So we have a lot of the old ways of data sharing is you and I sign a contract. We both agree we only use the data for X. We just trust, nobody verifies. The data inevitably ends up in a data lake. Somebody else uses it. We're in violation of contract or in breach of contract, and then we hit legal problems. So I think the old ways of data sharing are gone or will eventually be gone. And I think by creating more auditable, more transparent, and also safer ways of creating those data sharing flows, I think Flower is a tremendously promising way for people to start thinking through this in a new paradigm. But then we also get to kind of the business side of the house, which I know is maybe not where anybody in this room sits, but I want to touch on it too, is just how do we incentivize the ability to create new data partnerships or new data collaborations where people want to participate for either a common good or in some sort of incentivization structure where one company A pays company B for data, and how does that look and work? And so I think here, these are some key things that end up coming up quite often in an industry context and something that I'd like to share with you. So I wrote up some random ideas. So I had this kind of as a question to answer, but then I thought, why don't I just draw out some ideas that I had? And then if you like them, you can use them. I don't even need attribution, just do them. I would just be so happy to see them. But here's some ideas that I've thought about in problems that I've seen in this space. One of the problems that we have, let's say we have a magical federated analytics, which we can now get from Flower Analytics, and we have org A and org B. And let's say that we're replacing a traditional data sharing mechanism where data would just be transferred over. And now we want to do it in this more privacy aware way and also in a more secure and safer way and a more transparent way. So what if org A is sending org B the details and org B is collecting these maybe from multiple industry partners or other people that they work with and aggregating them together in some sort of dashboard or other thing that they use to make their decisions? What if org A, before the data was actually transmitted, had some sort of interface where they could actually start to think and reason about the information that they are actually sending over? What if even eventually they could say, no, I actually don't want to send this update. This update is too revealing. What if also we could use theories like information gain and other things to actually better communicate to them, is there a risk with sending this information? Yes or no, right? So we can start to think there of more consent-based user flows that allow some sort of, again, this helps with the fear and anxiety, that allows some sort of risk mitigation before any data is actually sent. From an org B point of view, then we also have some sort of user interface, some sort of metrics built in, some sort of dashboard, right? That may not be the competency of folks in this room, but that's eventually what somebody's going to use to make decisions based on the data that's collected. But what if we also had an auditable view of how this computation ran and who participated and who did not participate? And what if also that was signed in such a way that we could show it to our compliance board if anybody comes knocking from a regulatory aspect? And what if there's also some built-in privacy debugging such that if enough participants decide to actually reject a particular query or computation, that it's not actually put back to any one participant, but the computation actually fails. And it says, we skipped this query because it's dangerous. And what if that also ends up being semi-automated based on our idea of information leakage or privacy leakage of any one participant? So we can start to think of ways where we can build not only more transparent and consensual ways to have this data shared, but also ways to help the users from making an accidental privacy mistake. And I think that's a real danger that I've seen, and something that I think maybe we should address to help the users help themselves, basically. Okay, another set of ideas. Clustered aggregation is already a thing, and a thing that Flower can support. But maybe another thing that I've been thinking about a lot recently with some distributed learning setups that have been brought to my attention is the ability to select particular samples of the population based on other characteristics. So this might be characteristics that we already know. It could even be device type or something like this, right? But it could also be other connected characteristics that we have, like language, like region, like particular interests or other things like this. And or it can also be based off their behavior as we're doing a learning application. So how can we actually apply, I would almost say it like a population density or clustering mechanisms to the types of updates that we're seeing, and allow groups of like-minded users to learn together and to not have to conform to a global norm. And I think that when we think about particular consumer-facing contexts, like let's say recommendation algorithms, we may want to allow for some of this deviation, right? This is the same idea of multi-armed bandits and so forth. We may want to allow for this deviation, and then we may want to decide at one point in time, do we do a global alignment step, or do we just allow for a full deviation of the types of models from some sort of base state? And I think this is quite interesting for some of the reasons why I think industry wants to adopt this, and I think wants to potentially move towards more machine learning with friends or machine learning with my group rather than machine learning with everybody. And I think that this could be a very interesting area of research, is how do we actually identify those clusters, and also the research of, does this just produce more siloed effects of recommenders? And that's out of my wheelhouse of the ethical implications of allowing people to kind of learn with like-minded people rather than a more diverse group. I think though that it has some benefits as well, as in when we use more diverse data and we allow participants of a more diverse set, so to speak, than the global norm to train themselves, the model performs better for their data. Another idea, and this is what I'm very, very most excited about, but the technological barriers are quite high, is the concept of moving to a fully distributed machine learning setup. And the idea of this, it backs off of a lot of kind of the ideas of distributed identity services and these types of fully distributed setups. I think the question becomes, how do we actually collaborate across a series of participants without an aggregator at all? And how could that look like? How is that feasible? How is that possible? How is the coordination done? And then on top of that question, what's the actual root of trust model? So we have to have some sort of root of trust, kind of like a certificate authority for the internet. And we have to decide how exactly we're going to validate participation, validate participants. And then we almost always end up in the DID space, the distributed identifier space, or other ways of deciding, okay, how would I like to identify myself consensually online and participate? And what information would I like to reveal about myself in my participation, which I think also, of course, enhances privacy. Just a few more ideas, random ideas. Again, I am not a researcher, and again, I am not an expert in any of this field. These are just ideas that I have from thinking about it. So I would be very happy if somebody improves the ideas. So one of the things, I used to work in the field of adversarial machine learning, a bit. And one of the things that was quite common during that time of adversarial machine learning was the concept of, is it possible for us to think about the form of input validation? Is it possible for us to think about manifold-based autoencoders? So squeezing outlier examples towards a manifold, and then being able to then merge them, whether they're malicious or whether it's an error, being able to merge them more into a decision space that we believe is true. This has all sorts of problems too. This is not necessarily a be-all end-all solution for things. But one of the things that I've been thinking about is when we have this varied space and we have potential outliers, how do we, A, reduce the influence of outliers also for their own privacy benefit? And B, how do we determine malicious behavior when an outlier is just an outlier and when an outlier is a potential malicious participant? And how can we then converge things to a denser space that we believe to be true? And I think this area, I have yet to see a lot of work just on a federated point of view, but there's quite a bit on a centralized point of view. And I would be very curious to your opinions here. Finally, this is, I think, like the biggest message that I want to send today is like, I truly believe that distributed machine learning can fundamentally change the way machine learning operates in our world today. And I was so honored and excited to be here because I think it's such a promising future to think about consensual data use, to think about non-toxic data use. So I come from a field of language modeling. Language modeling has a lot of toxicity problems, a lot of ethical problems. And I think if we could shift to using data from humans, if I was able to use FedGPT to train on our text data on our machines, and we were able to share it because we know there's privacy controls, the level of toxicity of these models would automatically drop. And we could automatically have safer language models that people want to integrate with, that people have, that has more representation of our actual world and not just a toxic dump of things on the internet. And I'm really, really excited about a potential future where machine learning represents the needs of individuals and that people want to participate rather than feel like they're the victim of this participation. So on that note, I think if we distribute data, we also distribute control. And that when we build user-centric systems and user-centric data, which something like federated learning and something like Flower automatically does, is built into the core model, I think we create a new way of thinking about power and data in the context that we have now. And it becomes less who hoards the most internet sludge, and it becomes more who has the most consensual participants in some sort of new way of thinking about machine learning and modeling. So I want to say thank you. That's my book if you want to read it. And I have a newsletter if you want to read it. And I'm going to just leave these up as some thoughts that I wrote myself yesterday on some potential suggestions for research. And if we have time, I'll take questions.
Thank you so much. I love the way you organize the talk in the sense that many people talk about, well, here's the problems and here are the state of the art. Oh, sorry. They say, here's the problems, here's state of the art. And we all know what the limitations of state of the art are, but no one ever wants to really speculate too hard in their talks to really expose where we could actually go. So I really appreciate the fact that you did that.
Thank you.
We have time for questions. So who would like to, the guy in the, oh, let me run up there. Oh, yeah.
Thank you so much for the talk. That was really, really interesting. I mean, and fascinating, some of the ideas you put forward. I was particularly interested about the first idea you put forward in relation to actually implementing more privacy sensitive sort of consent forms prior to when the data is actually sent. And I'd be interested to understand a bit more like on your thoughts on like in relation to data literacy, and how do we communicate the implications of data and the impact before it's being sent? Because sometimes, like when it's being sent, we might not even understand the implications until after the model is being trained or until after the model is being sort of completed. So yeah.
Absolutely, and thank you. It's a great problem statement. I mean, I think one of the things in writing the book, I have numerous chapters that touch on differential privacy, and one of the things that I found most tragic is the lack of real user research and design in differential privacy mechanism systems, and the ability for users to reason about the potential for an edge case situation, so catastrophic loss or something like this, or B, even an average case situation, like how do we actually model average risk for an average user? And I think it's still a massively open research problem. And I had the pleasure last night of talking to a designer about this space and thinking through, from a UI UX perspective, we don't really even know how we should communicate privacy risk. So when you look back to the research on how do you even communicate privacy risk from the early days of the internet and what people were thinking about, there's some really interesting work. If you look up privacy nutrition labels, this was like a piece of work, I think from the 90s or early 2000s on privacy nutrition labels. And it was even just trying to tell people, like, when you go to this website, like, here's all the stuff we're going to do, and like, here's how many grams of this and that stuff we're going to take from you. And there was also some work called Privacy Parrot in IE6. And Privacy Parrot, first off, I just want to say, first cookie specification ever written was GDPR compliant. So just to let you know, that was the original cookie specs is fine. But also when the 90s first happened and people were starting to connect to the internet, I think people were asking more of these questions of how do we communicate to users the obfuscation of when they send this data, what actually happens? And that got kind of lost somewhere in the shift. I don't know, we can theorize as to why, but I think it's an area of research that we have to reopen. And particularly, I agree with you, the opacity of understanding if I contribute this batch of training, or if I contribute this tensor to this particular layer, what does it mean? I don't even think that we know how to quantify that well. And I don't think we can communicate. If we can't quantify it well, we can't also communicate it well to a user. And so basically, your question is amazing. You should go research it.
I think we had a question from online.
Sorry.
So the question is, could you explain your idea about adversary example and outlier detection?
Yeah, so I like I got really entranced by a piece of research called feature squeezing. If you've ever heard of it, it was a line of work, and I have a repo where I reworked the research repo many years ago now to do it. I don't even know if my repo will still work, but if you want a link, I'll try to send it to you. And the idea of feature squeezing was the idea of, can we actually reduce noisiness in the particular samples by squeezing it to a reduced space, and then reflecting it back from an autoencoder. There's an autoencoder that allowed us to take a multi-dimensional space, to squeeze it, and then to map it back to what we believe the space is that we should make decisions on. And this allowed for certain adversarial examples to be identified and essentially repaired. Because obviously, even when we talk about pixel-based attacks, we can imagine a situation where it's actually like a camera that went wrong. So like poor lighting or something like this was some of the first adversarial examples for self-driven cars. Was it actually like the models would perform abhorrently when they were dealing with low light situations or other types of situations? So natural adversaries, right? And this isn't like that's not the solved way that most people ended up handling adversarial examples. Most people just decided to do adversarial training, which is, yeah, potentially one thing if your search space is small enough. But the problem becomes is who can actually do adversarial training. That's massive. So sorry, back to the original thought is, can we, if we have a well-known decision space, presuming, can we build autoencoders that are based off of maybe some of these same ideas that came up in feature squeezing as a way to essentially correct for error in input systems, or at least reject things that appear outside of the boundaries that we're willing to make a decision on. So the idea of embracing uncertainty of a certain lower density areas of our decision space.
It's really interesting. Do we have other questions? Yeah, sure.
Yeah, thank you very much for your talk. Very interesting. You previously mentioned about privacy budget and privacy budget scheduling.
Mm-hmm.
Can you expand a bit more on this? And how do you think if we consider privacy as a resource, it could be fit into can help a decision making either for automation or for business decision?
Yeah, so so one of the core, you're familiar with the differential privacy budget. And so I was amazed to learn that most places that deploy differential privacy in production don't actually track budget in any type of real way on a per user, per contribution basis, which they could, but yeah, it's complicated. Yeah, it's fine. But that these budgets reset after a certain amount of experimentation or a certain amount of saying, okay, we collect these analytics with these privacy units, and at the end of those privacy units, then you reset. A really good disclaimer to read on this is the Facebook URLs data release. So if you've downloaded the Facebook URLs data set, if not, take a look at it. It's very interesting. But they have a really long explainer on why they chose the privacy units that they did, which is on a per action basis rather than a per user basis. And when we think about it and what they wrote directly, the thing is this indeed overexposes our super users in a significant way. So when we think about outliers, we have to, in differential privacy, we not only think of like people that are outside of normal bounds, but we also think about super users, so hyper users. So I can imagine in a flower setting that originally you're going to have some users that are like, yeah, this is awesome. And they're going to over contribute potentially, not in and we just want to communicate that to them. So I think in thinking through, do we want to track per device contributions? Do we want to track per identity contributions? Do you want to track a different type of privacy unit for your differential privacy settings? It's really cool that there's more customization coming, because I think you need to think about how to communicate to a user if they're, let's say, an avid flower user and contributor to the model that you're building. Not only does their data bias the actual model and outcomes, but B, how do you communicate to them that they're in a particular risk category that might be extraordinary compared to their peers, so to speak. And I think that's just, I think some of that is UI, UX and talking with the businesses as well of how do we want to actually talk about this? And maybe there's also a way for people to say, like, I actually want to reset my budget. I'm happy to contribute more if they're not part of the sampling selection anymore because you've decided, okay, the amount of information that they've contributed is at such a level we actually won't sample them for a few more rounds or for this model for the rest of the model's life. Does that answer your question though? Okay.
Yeah. Okay. Well, great. Thank you so much. I was sort of a bit low on time, so thank you again.
Awesome. Thank you.
And we're about to take a 15-minute break, so we're back here at 2:20. I'm looking forward to seeing you again.